So let's talk about the end behavior of our rational functions, right? We're going to move beyond the very basics of horizontal and slant asymptotes and talk about really what's going on, especially with a little preview of calculus. So we did this before in class. So let's just write back that really disgusting function we were just working with. So as a reminder, we were talking about what happens in behavior. Horizontal asymptotes are all about what happens as x goes to infinity and negative infinity, right? To either of those. So we did a trick in class to see what would happen. Because if we were to plug in infinity, totally not allowed, but we get infinity squared over infinity cubed. Like that's what we get something with an infinity squared over infinity cubed. We realize that that's bigger than all the other terms. So we can kind of say, eh, and yeah, I mean, technically, you could kind of think about this as being like, well, I guess we could cancel exponents. This is like 1 over infinity when you think about degrees. And something divided an infinite number of times will eventually be approximately 0. So that's the hand wavy math that you can do that just think about what's happening. But the actual pretty math that you do in calculus to actually find this limit is that you do a clever thing by multiplying through by 1 over that largest degree. So 1 over x cubed. So we multiply both the top and bottom through by this. I guess I can put parentheses around these. Doesn't really matter. So then we can rewrite this whole function. And so this whole function is now looking like 1 over x minus, right, my thing was being too glitchy. I just decided to pause and write it. So that's what would happen if we multiplied this 1 over x cubed to each term in the numerator and the denominator. And one of the things we are allowed to say in calculus, one of the things we proved pretty early on, is that any number over infinity is equal to 0. That's just like a mathematical truth that we're allowed to assume in calculus. And I think my shiz is going to do its little freezy thing again. Maybe it's not. Nope, it's frozen. Oh, there it goes. It's going to cycle back on. I'm taking a video, so I'm talking this through for the Microsoft people. Black screens everywhere. Ooh, this is a really long one. This is exciting. Oh, there. Oh, it's finally back. And all my video recording will be there. And it won't look like anything happened. All right. So one of the things we have in calculus is that that's fine. A number over infinity equal to 0 is fine. We can say that. So basically, we have 0 minus 0 over 1 plus 0 plus 0. This is all equal to or equivalent to 1 or 0 over 1, which is just 0. So this is why we can say anytime the degree of the numerator, we're going to be able to do this trick if we want to formally show this, anytime the degree of the numerator, oops, the numerator is smaller than the degree of the denominator, we're going to see this. We're going to have a horizontal asymptote at y is equal to 0. All right. So we also use this exact trick in class. In fact, I'm sure you'll see it in the old Jamboard from class to say anytime that the degree of the numerator is equal to the degree of our denominator. Oops, trying to throw this in there. Then we can use that same trick, and what's going to happen is it's just going to be still a horizontal asymptote, but it's going to be y is equal to, and then it's going to be uh, a over b, where a is the leading coefficient. Oops, I can't spell, especially when my Jamboard is lagging so bad that I can't see, of the numerator, and b is the leading coefficient of denominator. So we could look at an example like something like this. We don't have to know anything else about it. Oh gosh, it's freezing again. Kill me. Oh, that one was short. All right, so this one, let's say if we have an f of x that is 3x squared minus 2x plus 7 all over, I don't know, let's make this, how do we make this fun? We can't. Negative 2x squared plus 4. A little bit weird to have the negative in the denominator, but whatever. That this will have a horizontal asymptote because the degree is the same, right? We can basically say, and we're talking about infinities, we're talking about long run behavior. The biggest term is going to beat out all of the rest. They will not matter. This is just going to be 3 over negative 2. So our horizontal asymptote is going to happen at y is equal to negative 1.5 or negative 3 over 2. Same idea. So that's what happens when we have a horizontal asymptotes. Since this video is already a little long and I've already had so many glitches during it, I'll go ahead and do a second video where we talk about slant asymptotes and more.